To give up, you have to be dead, or completely incapacitated.
Capitals: Europe, Netherlands, Amsterdam. Andorra, Andorra la Vella. Greece, Athens. Serbia, Belgrade. Germany, Berlin. Switzerland, Bern. Slovakia, Bratislava. Belgium, Brussels. Romania, Bucharest. Hungary, Budapest. Moldova, Chisinau. Denmark, Copenhagen. Ireland, Dublin. Ukraine, Kiev. Portugal, Lisbon. Slovenia, Ljubljana. United Kingdom, London. Luxembourg, Luxembourg. Spain, Madrid. Belarus, Minsk. Monaco, Monaco. Russia, Moscow. Cyprus, Nicosia. Greenland, Nuuk. Norway, Oslo. France, Paris. Montenegro, Podgorica. Czech Republic, Prague. Iceland, Reykjavik. Latvia, Riga. Italy, Rome. San Marino, San Marino. Bosnia and Herzegovina, Sarajevo. North Macedonia, Skopje. Bulgaria, Sofia. Sweden, Stockholm. Estonia, Tallinn. Albania, Tirana. Liechtenstein, Vaduz. Malta, Valletta. Holy See, Vatican City. Austria, Vienna. Lithuania, Vilnius. Poland, Warsaw. Croatia, Zagreb. So this is some kind of diarrhea journal. Damn, what about drifting? Not today, son, not today. Brace yourself. Knowledge is coming. What is better than a Lamborghini? Agenda. CCNA. Whatever else. Reset. So CCNA. Drilling the subnets. Subnetting so-called Class A network. Let me take an example of IP range of 10.0.0.0. We need to divide this into 4 subnets. So. We will be having a new subnet mask for those 4 subnets. Okay. Fine. Let us see what is current subnet mask. Which is 255.0.0.0. Yeah. Since this is so-called Class A subnet. So to have 4 subnets out of this range we need mask 2 additional bits. I figured it is like square root of the subnets you need. Square root of 4 is 2. You might see that with this method we could potentially lose a lot of bits since, for example, square root of 3 is 1.732 and some. So for 3 subnets we also have to mask 2 bits just like 4 subnets. Anyway, our new subnet mask will be old subnet mask plus 2 additional bits. Our old subnet mask is 255.0.0.0. Converting to binary we will get 8 ones in the first octet and all zeros in the remaining octets. 2 additional bits will be in the second octet. We count from left to right. So new subnet mask will have 2 ones and 6 zeros in the second octet. This binary number corresponds to 192 in decimal. So our new subnet mask for 4 subnets is 255.192.0.0 or 8 ones in the first octet, 2 ones in the second octet, and remaining 22 zeros. Do you get it, son? Nah. Maybe commit more. So now we could find out the network IDs of those 4 subnets. First octet remain constant, meaning 8 ones. In the second octet we will be turning on and of those 2 bits. So. There are 4 different combinations, 00, 01, 10, and 11. The rest of octet is all zeros. Since we only change first 2 bits, you can convert these 4 combination into decimal values. So the values are 0, 64, 128, 192. Stay with me. The dumber the explanation the better. Feel the power of boredom. Do you get it, son? Are you committed? Yeah? So 4 subnet IDs. First octet stays the same. 10. Second octet respectively 0, 64, 128, 192, and the remaining octet stays the same 0 and 0. So 10.0 and 10.64 and 10.128 and 10.192, and remaining 0.0. Drilling the shy T out of this, yeah. Next first valid address. Which is the least significant bit turn on, meaning the value is 1. And in our case the value is 1 in binary and in decimal. So example would be 10.128.0.1. Now but. Calculate broadcast. Broadcast address is all ones in the host portion. So our subnet mask is 10 bits long, just say it for the sake of it. Meaning we have all ones in the first octet and 2 additional ones in the second octet. So broadcast address will be taking the network IDs and turning zeros to ones in the host portion. Now, first octet will not change. Yeah. It will be 10. Let's us skip second for now. Third and fourth octet also will be the same. Since we had all zeros there. Turning zeros to ones will make the decimal representation of it to 255. So we have 3 out of 4. 10 and 2 255. Now we will have to do some binary math to calculate the second octet to get a broadcast address for each subnet. Remember we are changed 6 out of 8 binary digits. Since we borrowed 2 for the subnet mask. Remember the values. 00, 01, 10, and 11. Now the rest should be ones in all the remaining places, meaning 6 ones. Do you see what I say? Yeah. It git. Long story longer. Let's try to come back from this mess. First subnet second octet binary is 00 and 6 ones. Second, 01 and 6 ones. Third, 10 and 6 ones. Fourth, 11 and 6 ones or 8 ones. Duh. So now decimal representations. First is 63, second 127, third, 191, and fourth, 255. There you go. Did you came back from the rabbit hole? Not likely. We will do some maybe forever. Till we find the perfect expansion. Yeah. Now last valid address will be the broadcast address plus turning the least significant bit off, meaning making it 0. So since we have all 8 ones there, this is some very easy. Every subnet will have 254 in the last octet. So to summarize this mess. 4 network IDs. 4 first valid addresses. 4 last valid addresses. 4 broadcast addresses. And 1 subnet masked to rule them all. The formula for number of subnet is 2 to power of subnet bits equals number of subnets. Meaning to find the number of bits to mask you need to take a square root of the number of subnets needed. To find the number of hosts per subnet you take 2 to power of number of host bits left minus 2. So let's say subnet mask is 10 bits. You left with 22 host bits. So 2 to power of 22 minus 2 is around 4 million. Boom. Too long did not read. Bye. Day what? Day 20. NDR, non-delivery receipt. NetBEUI, Network Basic Input or Output Extended User Interface. NetBIOS, Network Basic Input or Output System. NFC, Near Field Communication. NFS, Network File Service. NGFW, Next Generation Firewall. NIC, Network Interface Card. NIDS, Network Intrusion Detection System. NIPS, Network Intrusion Prevention System. NIU, Network Interface Unit. rabbit1 is the most widely deployed open source message broker. With tens of thousands of users. Okay, whatever. What is the message broker? A message broker, also known as an integration broker or interface engine, is an intermediary computer program module that translates a message from the formal messaging protocol of the sender to the formal messaging protocol of the receiver. Message brokers are elements in telecommunication or computer networks where software applications communicate by exchanging formally defined messages. Message brokers are a building block of message-oriented middleware, MOM, but are typically not a replacement for traditional middleware like MOM and Remote Procedure Call, RPC. Okay. What is message-oriented middleware, MOM? MOM is software or hardware infrastructure supporting sending and receiving messages between distributed systems. MOM allows application modules to be distributed over heterogeneous platforms and reduces the complexity of developing applications that span multiple operating systems and network protocols. Heterogeneous meaning diverse in character or content. Comm created a distributed communications layer that insulates the application developer from the details of the various operating systems and networks interfaces. APIs that extend across diverse platforms and networks are typically provided by Comm. Okay. Fine. What is RCP? Remote Procedure Call. In distributed computing, RCP is when a computer program causes a procedure, subroutine, to execute in a different address space, commonly on another computer on a shared network, which is coded as if it were a normal, local, procedure call, without the programmer explicitly coding the details for the remote interaction. Okay. What? What is address space? In computing, address space defines a range of discrete addresses, each of which may correspond to a network host, peripheral device, disk sector, a memory cell or other logical or physical entity. What is disk sector? In computer disk storage, a sector is a subdivision of a track on a magnetic disk or optical disk. Each sector stores a fixed amount of user-accessible data, traditionally 512 bytes for hard disk drives and 2048 bytes for CD and DVD-ROMs. Newer HDDs use 4096 byte sectors, which are known as Advanced Format, AF. The sector is a minimum storage unit of a hard drive. Most disk partitioning schemes are designed to have files occupy an integral number of sectors regardless of the file's actual size. Files that do not fill the whole sector will have the remainder of their last sector filled with zeros. In practice, operating systems typically operate on blocks of data, which may span multiple sectors. Any messaging broker. The primary purpose of a broker is to take incoming messages from application and perform some action on them. Message brokers can decouple endpoints, meet specific non-functional requirements, and facilitate reuse of intermediary functions. For example, a message broker may be used to manage a workload queue or message queue for multiple receivers, providing reliable storage, guaranteed message delivery and perhaps transaction management.